I would hear his voice from down the hall, Uncle Bob, Uncle Bob. And it was just like, okay, Billy, shut up. But, I mean, it ended up working out okay.
Hello and welcome to That Tech Show with me, Samuel Gregory and Chris Adams. The show that reveals the magicians behind the magic that is everyday technology. And boy, do we have a magician for you today. As on today's episode, we have the one and only Uncle Bob Martin.
This is a big one for us. Bob is a legend in the computing world, best known for his role in establishing test-driven development, the solid principles, being one of the signatories of the Agile Manifesto, and of course, clean code. He's perhaps the first celebrity programmer that I became aware of around 12 years ago when I started at the BBC. He'd been to the BBC and given a presentation about 2 months before I arrived, and everyone was talking about him. So it's taken a little while, but finally Sam and I, get to speak to him and learn how someone as big an influence as Bob gets to be Uncle Bob.
Billy Frisco is cleaning himself, by the way, just to let you know.
Sponsored by Billy Frisco, this episode.
Bob has had his fair share of controversy over the years, and we get into all that. But what was important to us is that it was his impact basically on the technology industry and ultimately the world, which should give you an understanding of the breadth of his impact.
Yeah, I don't think I've worked anywhere where TDD, solid, agile, or clean code hasn't been mentioned.
Cool. So if you're new to the show and you're on YouTube, please drop us a comment and let us know your thoughts about the episode. We love getting stuck into the community down there. We're also nearly 1,000 subscribers, so please help us get there. That would be a fantastic milestone for us, and of course, show your support with a like. There's a lot of book recommendations in this episode, so all of those affiliate links are down in the description or over in the description, wherever you are, for you to purchase should you choose to, and that will also obviously support the show. And finally, we're still registering interest in That Tech Show Live, so head on over to thattech.show and click on the big yellow banner.
Well, let's get to it then. Here's Uncle Bob.
My name is Bob Martin, Uncle Bob, and I'm a programmer, and I will be a programmer until the day I die. They will find me with my nose stuck between the keys of the keyboard.
That's fantastic. I love that. You know, I'd really like to start by diving into like how you got to being known globally as Uncle Bob. How the hell did that happen?
The Uncle Bob story, yes. So the year is 1988, and I am working at a company in Illinois, a startup called Clear Communications. And we hire a fella whose first name is Billy. I won't tell you his last name. And Billy had nicknames for everybody. And it just so happened that he called me Uncle Bob. I don't know why he called me Uncle Bob, but he did. And it was very annoying. Uncle Bob, come here. Uncle Bob, do this. Uncle Bob, what about that? So I eventually left that company. And to my relief, nobody was calling me Uncle Bob. And then I noticed that I was missing it. Nobody was calling me Uncle Bob. So I made the mistake of putting it in my email signature, which was at a time when I was doing an awful lot of social network emailing on an old social network called Usenet that programmers used a lot. And I left it up there for a year. And then I was at a conference one day, and somebody saw me and hollered out, Uncle Bob. And I realized that I'd made this horrible mistake. And I took it out of my email signature, but it didn't matter. Everybody continued to call me Uncle Bob. And at some point, I realized that it was probably a good brand. But it was entirely by accident that occurred.
It's that kind of parental-ish type of nickname. So you kind of own this, you know, you're the uncle of all coders, you know?
Yes, well.
So it was 88 then. So how old were you in 88 when you were being called uncle?
Oh, heavens. I was born in 1952, so that would have made me, 33? Did I do that math right? I think so.
So at 33, you were getting called uncle? Is that why you disliked it so much at that point?
No, I disliked it because he was annoying.
Fair enough.
That's all. I would hear his voice from down the hall, Uncle Bob, Uncle Bob. And, it was just like, okay, Billy, shut up. But, I mean, it ended up working out okay.
So years later, when you started using this on that, what was the name of the social network again? I've just forgotten.
It was called Usenet. This is early internet stuff, all text-based. dial up. It was really not internet. It was kind of the predecessor to the internet.
So what sort of year are we talking here for Usenet then?
The same year, 88, 89, 90, those kinds of years, yeah.
Yeah, so actually, as you say, precursor to the internet as a whole.
Yeah, the internet was there, but it was a backbone, and everybody kind of dialed into computers that dialed into other computers that dialed into yet other computers that eventually put their messages up on the internet. So we could do email, we could do social network news, but it was slow. It was, a day turnaround for all that stuff.
What were you posting?
Oh, I was very aggressive. I was talking about object-oriented design and C++. I was a C++ guy. I had read the ARM. I'd read all the books, and I was arguing with people, and there were people who would argue back with me. And it's same old stuff, same old flame wars that you get on Facebook or Twitter. It's just that we were doing it in a different medium in the 80s.
And what was your basis to say that I'm right and you guys are wrong, sort of thing? At this point, how much experience had you had in C++, or you just like to get people riled up?
Well, so let's see. Did I do this math right? Yeah, I did the math right. I was about 33 years old. I started programming very young, right? I was 12 years old when I wrote my very first working program. I got my first job as a programmer at 18. So I had been a programmer for a long time at this point, and felt like I had achieved some level of maturity. And so I would yell at people on this social network, the Usenet, and we would argue and argue and argue about the right way to do objects and the right way to do software. It was tons of fun. I learned most of my debating skills then.
I bet you. Well, I mean, correct me if I'm wrong, but you learn stuff by exposing yourself like that, because some people say stuff back, and even though it's hard to hear, it's like you kind of got a point there.
Absolutely, we all miss is the wrong word. We all underplay the value of disagreement. Disagreement is where you learn things. It is no fun to talk to people you agree with. Right? But if you can get into a really good argument, right, then you can learn something. You might not change your mind, but you will get a new perspective. You will learn. So I do that all the time. I'm arguing constantly. I used to argue on that network, and nowadays I argue on Facebook and Twitter, and I continue this debate mindset. I like to debate with people. It's the best way to learn something.
Well, the internet has just become one constant argument, I think, in a large part, hasn't it?
Well, and unfortunately, it gets uncivil, and then that's when I have to shut down, the idiots who come in and start calling me names. But other than that, if I can find people who are willing to aggressively debate ideas, that's gold. That's gold. And these are some of my most valued interlocutors, right? I look to these people that I disagree with fiercely with great affection.
It feels like you were on your social game very early on. Now, are you on TikTok? I feel like you do well on TikTok.
Oh, no, heavens no. TikTok, good God. No.
Oh, you do well there.
I stick pretty much to Facebook and Twitter. I haven't gone into the Instagram, TikTok, other world like that. I like being able to sit down and write something over a period of time. Twitter is one of those things that there's an old saying. I think it's attributed to Voltaire, right? I'm sorry this letter's so long. I didn't have time to make it shorter. Well, Twitter forces you to make it short. So I spend a lot of time composing messages on Twitter so that they will fit into that nice little package. People often say that Twitter is not a good medium for communication because the message size is so small. I disagree. I think it's a great mechanism for communication because it forces you to really think through what you want to say and get it down to a nice, short little packet. And then I use Facebook too, because then I don't have to get it short. I can spew out all kinds of long sentences and then look it over and see if I want to post it or not.
As someone that's such a large figure in the engineering community, do you find that the sort of stuff that you are putting out on Twitter or Facebook, do you find that becomes more divisive because of your profile that you have?
Oh, sure. Because if I say something that people don't like, They know I've got a large audience, so I'll get a whole bunch of people crawling out of the woodwork to come back at me and call me names, or just to post some kind of thing that I did 20 years ago, and they say, "Look, if he was an idiot back then, he must be an idiot now." So
Yeah, I mean, I didn't want to go straight into this, but it was obviously something I wanted to talk to you about. Is that you seem to be a little bit of a victim of cancel culture, right?
There have been attempts.
They tried.
They try. Yeah, they try. Victim? No, I'm not a victim of anything. There have been people who have tried to shut me down, but it hasn't worked so far. Let me just say that.
Because I'd seen that there was something I'd seen from probably about 10 years ago, which I have to be clear, before we booked you on the show, I was completely unaware of this. So your profile stands alone without knowing any of this other stuff. It doesn't come across in your books, for example. But there was some stuff I'd seen from about 10 years ago where you'd issued an apology for what was deemed as a sexist comment that you'd made.
Oh yes. Oh my goodness. Yes. That was that started at a Rails conference, and I gave a keynote talk. And in the midst of that keynote talk, I compared Java to estrogen and C++ to testosterone. And that was a stupid thing to do. I got a lot of laughs. That was what it was for. It was a joke, but it was a stupid joke. And somebody called me out on it, and I realized, oh, yeah, that was a stupid joke. So I put an apology up on GitHub. I think it's still there.
I just read it, so I can confirm that.
So yeah, it's one of those things. If you're a programmer, you put things up there, and said, yeah, that was stupid. Sorry about that. And most people said, okay, that's great. We're glad you're sorry. And a couple of people refused to accept the apology, and one in particular has had a vendetta against me for a very long time because of that. What can I say?
Well, what do you mean that they've had a vendetta against you?
I'm not going to name the person. It's just that that person has managed over the years to gather a fairly significant Twitter following and recruits people to try to cancel me. It's the same old thing.
Because I'd seen another thing as well, which was calling you out for, I think, more of your political views. Which, but I'm wondering if it's the same guy, because at the bottom of the article it says, and by the way, I've never read any of Uncle Bob's publications, which just seems like maybe they do have a vendetta. I don't know. I mean, what was that about?
I don't know. I don't remember that one, and probably not the person I'm speaking about, because that person has read my stuff. So yeah, probably not the same thing, but it's not unusual if you've got a fairly high profile. You're going to attract people who want to take you down.
You said you started learning to code at age 12. I mean, what did your parents do? Were they have any interest in computers?
No, not at all. My father was a science teacher, so that's some of my technical side. My mother was a nurse. And yeah, she was a registered nurse, worked in the operating room, surgical nurse, handing the instruments to the doctor, stuff like that. And that was the world I was brought up in. I got involved with computers at the age of 12. My mother bought me a little computer. It was a plastic machine, had 3 little sliders in it that were flip-flops representing 3 bits. It had 6 little pieces of metal that would slide into grooves on those flip-flops. Those were AND gates. And there was a mechanism in there that would allow the AND gates to change the state of a flip-flop. So it was, in essence, it was a 3-bit finite state machine. And you programmed it by putting little soda straw segments onto pegs that would block the rods from slipping into the grooves. So that's how you put the inputs into the AND gates. And if you think about it, right, you've got 6 AND gates that can take 3 inputs, and they can invoke changes to 3 possible bits. So there's a fair bit you can do with that. And that fascinated me. I was just completely entranced by that machine.
What were you doing on those machines? Like what?
Program would be a counter, would count from 0 up to 7 and then back to 0. I learned octal on that machine. You could program it to count backwards from 7 down to 0. You could program it to do a full adder. You could add 2 bits and get a sum and carry out. That was a little tricky because you had to replace 2 of the AND gates with an OR gate, but that was a little plastic thing that you'd slide in there to do that. And there were a number of other little puzzles that you could solve. There was 20 some odd puzzles. And in the end, I wrote to them and said, hey, I need to know how to program this machine because I don't know how to program. And they sent me a nice little book that described Boolean algebra. And I inhaled that book and then could figure out how to make the machine do what I wanted it to do.
And so how long did that keep you busy then?
That little machine, probably 6 months or so. But it set the course of my life. From that point on, I was just inhaling anything about computers that I could.
So where did you go from that then? What was the next step?
My neighbor across the street, I've never told this story, so interesting that you asked. My neighbor across the street worked for Teletype, and he learned of my interest in computers, and he brought me home a box of several dozen relays. Now, I'd never seen a relay in my life. I didn't know what the heck they were, but I looked at these little devices, and they have a little coil of wire, obviously an electromagnet. And if you energize that coil of wire, which I did with an electric train transformer, I could make it pull in a little piece of metal. There was a little piece of metal on the relay, and you could turn that electromagnet on. It would pull that piece of metal in, and as the piece of metal moved in, there were levers that would change the position of switch contacts. So some of the switch contacts would open, some of them would close, and they were very rich relays. They had lots of contacts on them. And so I would sit and wire them up and get a soldering gun out and solder things together with bell wire and get my electric train transformer and hook it up. And I would make these relays do things similar to the way this little plastic computer that I had used had done things. There was a very interesting analog between those two. And I came up with a number of designs for different kinds of computers and different kinds of things that I could build.
So what sort of things were you building though? I mean, what were they? What were these things able to do?
The one that I was working on, and I was probably 13 or 14 at this point, and I was trying to solve the game of NIM. The game of NIM is when you've got a pile of stones and two players, and you can take 1, 2, or 3 stones from the pile. And you take turns doing this, and the goal is to make your opponent take the last stone. And so that's an easy to solve problem. It's a modulus arithmetic problem, but I didn't know anything about modulus arithmetic in those days. So I put together a little circuit that would do that. Right? It was just I spent days on this thing. I got plywood out. I built a chassis for it. I put switches on it and lights and all kinds of things. It was a very massive machine with, 12 relays inside and a transformer, and you'd plug it into the wall and it would and try and calculate the answer. Made all the noises a computer ought to make in those days, the clicking noise that you hear on Star Trek, the original series, right? Yeah.
That's a thing we really miss these days, isn't it?
Yeah, the computers on Star Trek, the original series, made relay noises. Clickety, clickety, click, because that was traditional in those days.
Did you solve it?
The circuit would have worked.
Would have.
But what?
But my wiring technique had a few problems with it. Number one, my mother gave me a staple gun. And we thought, okay, what we need to do is run these wires, bell wires, the kinds of wires you use for a doorbell. And I would run these wires around the plywood, and then I would staple them down with this staple gun. Well, the staples were brass, and they went through the wires with enough force to cut the insulation. So every time I stapled wires, it would short them together. I didn't know that. So I'd put this thing together, and then I'd hook it up, and the transformer would go, and I'd have to unplug it and try and figure out where all the shorts were. And in the midst of all that, while I'm trying to debug this thing, I made a new friend. And this friend became a lifelong friend. And he and I concocted schemes. And he knew much more about electronics than I did. So we embarked on a different project, and I set that one aside. And we went and started to build a calculator, a binary calculator. And for this one, we used integrated circuits with, real flip-flops, RTL circuitry, and AND gates and OR gates. And we'd build our own out of transistors. We learned a tremendous amount, reading popular electronics. And we just were inhaling all this information. And we actually did get that one to work. This was a nice little machine at 18 bits, add, subtract, multiply, and divide. Got that thing to work The summer after freshman year of high school.
Who were your idols at this time? Who were you looking up to or looking to for inspiration or learning or any type of thing?
At that time, I didn't know anything about programmers. So I can't point to people like Edgar Dijkstra or folks like that. But I did know about scientists. So I could look at Albert Einstein, for example, or Dan Posen or Richard Feynman. There were people whose names I knew. But keep in mind also that I'm 15 years old. And at 15, you're not looking into the past very much. You're looking into the future a lot, but you're not looking for inspiration from the past. You think at the age of 15, you think everything is ahead of you and there's nothing behind you.
I guess it's more to do with looking out at the world around you. Like, so for instance, maybe someone like, I mean, he's dead now, but Steve Jobs might have been a current thing we look to of like, or Elon Musk, maybe another person. I know he's very divisive, so we won't get into that. But
Certainly.
we look at people around us doing great things. People look to you, Bob. People look to you about what you're doing. You know, we have these mentors or these people who inspire us to, I want to be like them or something like that. So were there any current people around at that point who were doing similar things?
At that point, while I'm 15 years old, how many programmers were there in the world? And and the answer to that is, well, probably tens of thousands, but none that you would have heard of. Right now, nowadays I can go back to that period and I can say, well, there's John von Neumann was back there, Edgar Dijkstra was back there, and there was people like Jarno Strustrup who was studying Simula. You've got all these guys who did work on Simula 67, Ole Johan Dahl, Christian Nygaard, all these guys who did really great work. But at the age of 15, I didn't know who any of those were. I was just thinking Fortran and COBOL. Those are the great languages of the day, and assembly language. Oh, I learned how to program on a PDP-8 at that age. A little mini computer, right? Yeah.
Because we know people from the internet. You know, we find these people from the internet. So it would have been, I don't know how you would even know of people outside of your local town at that time or whatever. So it just seems very the early days of programming and the internet at this stage, and just interested to know what was around or how you would learn. So basically you're just trying to outdo your friend maybe and trying to one up your friend or something like that to get better.
He was much smarter than I was, so I couldn't outdo him at all. I just kind of followed along like a puppy dog half the time.
What are they up to now?
He passed away of, I believe it was of COVID, about 3 years ago, about 2 years ago, just at the height of the pandemic.
That's such a shame. I'm sorry to hear that. But how did their life unfold after being, better than Uncle Bob at programming?
Well, he did not go on to be a programmer, although he and I had several jobs together in the early days during our late teens and early 20s. And we were programming in those days. But his real passion was electronics. So he went on to become a kind of Uncle Bob of electronics. He would go off and do special projects for the Olympic teams. So he would build systems that would help the rowers measure the force profiles as they were rowing. And he was a rifleman, so he would set up automated targets for the Olympic shooting team. He did work like that, very custom, very specialized electronics work, and he was absolutely brilliant. And if you asked him to do something, he would sit and think about it for a little while, and then he would put together the most masterful project that you can imagine. I was always in awe of him.
What's his name if people want to look him up?
His name is Tim Conrad, Timothy Michael Conrad. Very good friend of mine.
Well, I'm sorry to hear that you lost your friend, Bob. That's really sad. Going back to those early days, though, was your first foray into work then as a programmer, or did you find your way into that later on?
So, well, I mean, as a teenager, I had a number of strange jobs, like I was repairing lawnmower engines for a while, and
it's very mechanically minded early on, I guess.
I wasn't good at it. But I did have that job, and I understand how an internal combustion engine works. But very early on, I was probably 18 years old. I got a job as an offline printer operator, third shift. Right, so from 11 at night until 6 in the morning. And what we were doing is we were printing junk mail. This was very early in the whole junk mail industry. There was this period of time when nobody ever got junk mail. And then suddenly people started getting this mail that was advertisement. And the junk mail was personalized. So you'd open up this letter and it would say, "Hello, Mr. Martin. Did you know that you and other people who live on Witchwood Lane," and you could tell that your name had been inserted by a different kind of printing mechanism, right? And your address had been inserted by a different kind of printing mechanism. I was one of the guys running those printers. And they were standard computer line printers that were reading magnetic tape, and the magnetic tape had the formatting on it, and the printers would print on pre-printed forms. We would bring these things in giant rolls that weighed 1,000 pounds, and we would mount them on tension-armed rollers that would feed the line printers. And of course, at this place where I was working, there were programmers. So, if I happened to see a programmer, I would go to that programmer and say, "Hey, what are you working on? Let me see your code, blah, blah, blah." And eventually I got hired by that company within about 6 months as a programmer, still probably 18 years old.
So that was the early inspiration then of actually seeing programmers programming, I guess.
Yeah, sort of. I thought I was smarter than any of them. What can you do?
I think that's really interesting though, because early on this certainly happened to me, as I thought I was a lot smarter than everybody in my 20s. Do you think you grow out of that?
Yes, you definitely do. Knowing Tim Conrad was a very humbling experience because I knew I wasn't smarter than he was. And so nowadays I have a much more nuanced view of what it means to be smart in general. And who is smart and about what they are smart. And I think it was I can't think of the guy's name. He used to give talks while doing a lasso back and forth, and he would say,
That sounds bizarre.
"Yeah, well, it was this is a guy from the 1930s, and I can't think of his name for some reason, but he would do these stand-up comedy routines, and one of the things he said, I think everybody's ignorant. It's just about different things."
That's a good perspective. So this sort of, I suppose it's ego. I class it as ego for myself. Is that what drove you through your 20s then to get to the point that we started off with talking about Usenet?
What drove my career through my 20s and into my 30s was just this never-ending passion for writing code, solving the problems, organizing the code, getting the code properly partitioned. There's some mental defect that I have in my brain that forces me to just want to do that all the time.
How are you writing code at this particular moment in time? How is it structured? Where is it written?
So the first kind of codes that I wrote were COBOL programs, which terrible language. Fortunately, I didn't have to do that for more than about 3 months. And then I got involved with mini computers and writing assembly language. And I stayed as an assembly language programmer for 12 years, 13 years. And thought any other language was foolish and ridiculous. No one should ever write in these other languages. Assembly language is the only true language. Real men do assembly language. That was my kind of, ridiculous mindset. And I didn't break out of that mindset until 1979, when I accidentally heard someone mention the language C. And I thought, oh, well, that's just another one of these dumb high-level languages like Pascal or something like that. But I happened to get a book on it because I like to read books. And I read this book outside by the campfire in my backyard. I read Kernahan and Ritchie. And I just fell in love with the language. It was assembly language. It was just assembly language with a different syntax, a better syntax. And I actually have that book, that original copy of Kernahan and Ritchie. I keep it in a Ziploc bag, and if I open it up, it still smells like campfire smoke.
The little things.
It's nice that you preserved the smell.
Yes, right, yeah.
These are all very low-level languages, very close to the metal, I guess. How important do you think that is for people to? Because I write front-end code. How important do you think it teaches one a lot of useful things, knowing those kind of languages, or would you recommend that to everyone looking into these sorts of languages, or do you think people can thrive and exist on some of these more high level coding languages?
It's kind of like learning to drive a manual transmission versus an automatic transmission. It is convenient to drive an automatic transmission, and I would not recommend that anybody who has a casual relationship with driving learn a manual. On the other hand, if you learn a manual transmission, you understand a lot more about that car. You understand it, and you also have powers that an automatic transmission does not have. You have techniques that you can use to work your way around the road by shifting at just the right time and using the clutch in just the right way. You have a more intimate connection with the machine that you are controlling. The way I tell programmers is this: if you have never written assembly language, then for you, there is still magic in the world. If you once program in assembly language, all the magic goes away. And you finally understand just exactly what these machines are and how moronic they are.
I remember writing my first assembly program with university, and I think it took me about a week to write Hello World, if I remember rightly. But it was my first foray into it, so that's my excuse.
Yes, well, I loved programming in assembly language, but nowadays I do not. I do not want to program in assembly language anymore. I choose other lower level languages. The language I'm using at the moment is Clojure, which is a very pretty little Lisp variant.
Yeah, we've had a Clojure expert on the call before. Is it on the show before?
Who is that?
Magnar? Oh, that was so long ago. But yeah, he did Clojure for zombies.
Oh, lovely.
Yeah, it's an interesting. He's created an interesting little website to teach you how to write Clojure with zombie-based programming, which is always interesting. It's important to remember the zombies. So going from C, then, I mean, it sounds like you've made a pretty quick switch from going, actually, C is this new exciting thing. Has that always been a thing that you've continued to do, to find new things and explore them? Obviously, you talked about moving into Clojure now, or is the, how deeply set are some of your opinions is what I'm wondering.
There's an old saying that you should learn a new language every year, and that's something that I have done pretty reliably. So over the years, I learned an awful lot of languages, going all the way back to Fortran, COBOL, and Snowball, and things like that. And then I was never impressed by any of them. I thought, these are just high-level languages for weenies. And then I found C, and I thought, C, that's a language. That's a real language. And I inhaled it. I learned it really, really well. And then shortly after that, 5-6 years after that, I started stumbling into C++. And I had already played with Smalltalk a little bit and thought, well, Smalltalk's interesting, but it's kind of slow, and it's another one of these high-level languages. And then C++ comes along, and I'm looking at that going, well, no, okay, all right, this is a serious language. It's better than C. It's better. It has a better typing structure. It's got object orientation. It's still C, though, so I could tolerate it. And I became a C++ aficionado and learned it cold. I inhaled everything I could about this language and followed it for a very long time and became a very accomplished, if I say so myself, C++ programmer. And it was in the midst of that I decided that I was done working for other people and started to hang out a shingle as a consultant and offer my services as a design consultant and a C++ expert, traveling the world yelling at people about how they're doing everything wrong.
That's an interesting shift, I suppose, from being a programmer to being a teacher. So what year are we talking here?
Oh, heavens. That would have been 1992, probably. And this is all due to my wife. My wife kept on saying, Bob, you should just become a consultant. You should stop working for these people. They make you miserable. You should become a consultant. And I thought, no, I'd never be able to make it as a consultant. Nobody would hire me. I need to work for a boss. And my wife was fairly persistent. So at some point I got an opportunity.
Did you already have a profile at that point? I mean, how do you go about finding your first gig?
So I'd already been on this Usenet thing that we were talking about. And I'd gained a fair reputation there as a C++ expert and as an object-oriented design expert. People were sending me emails, asking me questions, and I would answer them. And people would send me network posts and ask me to answer questions, which I would do publicly. And so that gave me a fair profile. People knew who I was. And the people who were using that at the time were programmers, of course, but there were also other people using it, and they were headhunters. And headhunters would scan these news group lists for people who looked like they knew what they were doing. And then if they had a position they thought they could fill, they would call them up. So I got a call from a headhunter. And at the time, I was reading a book by Grady Booch, the Object-Oriented Design with Applications. That was the name of the book, and it was a very famous book of the day about early object-oriented design. And as I'm listening to this headhunter talk to me, I inferred that this was going to be for Grady Booch's company, the company that Grady Booch worked at. And I thought, oh my God, I have to go there. And so I managed to negotiate with those folks. And yes, sure enough, that was it. It was a consulting gig at Rational in Santa Clara. And yes, Grady Booch was there, although he lived in Arizona, and I only saw him a few times. But I made friends with him, and he helped me. Get my first book published. And it was right around that time I started thinking I should write a book.
So this is designing object-oriented C++ applications using the Booch method.
There you go. That was the one. Yeah.
See, I've got the list in front of me. But yeah, that's it. That's fascinating that was the sort of pre-LinkedIn method of recruiters finding you, actually. But how fortuitous that you ended up working with someone that you admired so much.
Yes, indeed, and that set the stage. After that, I just kept on getting more and more customers. I've never had to really advertise or anything like that.
So was the book a big hit?
It was not a big hit. It was a hit. It was good. People bought it, but it was completely outdone by design patterns. Eric Gamma, Richard Helm, John Kern. Oh my goodness, I'm forgetting the name. Gamma, Vlasides, Helm, and Johnson, Ralph Johnson. Those four guys wrote the design patterns book in that point. It came out at exactly the same mine did, exactly the same time mine did, and just completely overwhelmed the entire software publishing arena. So, and deservedly so. It's probably the most important book written in the last 35 years.
So we've all got our little side projects going on. Have you hired some people to work on your little projects?
Oh, absolutely. I'm useless at design.
There's a few services out there, though, right, to find people. Where do you go?
The best place that I've gone, if I was to pick one of these services, is probably Fiverr.
It's a bit misleading, though, isn't it? Because they're not going to be a Fiverr.
No. But, with all these side projects, we don't want it to cost the world. We just want a little bit of help on a little bit of copywriting or a bit of design that we can't do ourselves, and shouldn't really attempt to do it because you're going to do a bad job otherwise. If it's not your kettle of fish, don't boil the frog.
There's a mixed metaphor if ever you heard one.
Get someone on Fiverr. They'll do it much quicker. The prices are very, very reasonable, unless you want to go to the Fiverr preferred members, and get your startup up sooner.
And you can throw into that tech show at the same time by heading over to thattech.show or taking a look in the description and clicking the affiliate link, and you can try out Fiverr and you can be supporting That Tech Show whilst you're doing it.
Because we get a little bit of a kickback. Give it a go. Venture into the world of outsourcing. Your life will change at Fiverr.com.
What happens then between your book coming out and, I suppose, what seems like a momentous occasion at the start of the millennium with the signing of the Agile Manifesto, which seems like the Book of Independence for software, or the Declaration of Independence for software engineering? What happens in the midst of that, leading up to that momentous occasion?
So 1995 is an interesting year because the Patterns book had come out. And a couple of years before that, a conference had been started, which was called PLOP, Pattern Languages of Programming, PLOP. And it was done in downstate Illinois. And it was one of those small little conferences populated by all the people I knew. right? With these gurus. Jim Copleen was there, Kent Beck was there, Ken Auer was there, lots and lots of people that I knew, and I knew their reputations, and we were all competitors with each other because we were all consultants. And we would go down and we would yell at each other and talk about each other with things. And it was at this conference that papers about lightweight processes started to show up. So Ken Schwaber and Jeff Sutherland and Martine DeVoe published a paper on Scrum. And nobody heard of Scrum, but okay, Scrum, that's interesting. Okay, an interesting lightweight process. It's not waterfall. It's something better than waterfall. And let's see, Jim Copleen published a paper called Patterns of Architecture, I think it was. But in there, he also talked about the best teams follow a really lightweight practice, blah, 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 blah. And this whole notion of lightweight started to percolate right around 1995, 1996. And this is right at a time when I'm at my peak of C++ consultancy. You know, people are hiring me to travel around and help them design C++ applications. And then they start asking me these questions that I was not prepared to answer. What process should we use? And I don't know what process is. I'm a programmer. I don't want to talk about process. But I got this question so often that I thought, well, okay, I need to do some research on this. And in my research, I stumble across Kent Beck again. I had already met Kent Beck before. I knew him from the Patterns group. But here he is. He's posting this stuff about extreme programming. I thought, what the devil is this? And I read about this and think, oh, that's actually fairly interesting. I don't know about this test first nonsense. That's just silly. But the rest of it sounds pretty good. And it just so happened by 1999, I was in Munich at a conference, which is still going on today. It's the OOP conference, usually February in Munich. And I'm teaching a class on C++. And I step out of my classroom, and out of the opposing classroom on the other side of the hall steps Kent Beck. And I say, hello, Kent, how are you? Yes, hi, Bob, how are you? Hey, you're doing this extreme programming stuff. Yeah, well, we got to talk. So we go down to the lunchroom at lunchtime and start to talk. Turns out that I am the editor-in-chief of the C++ report by this time, and I'm talking to Kent Beck about extreme programming. And by the time we're done with lunch, I realized that I need to get his ideas into that magazine. So I asked him to write a column for me, which he does, and we publish it to rave reviews. And I'm thinking, we got back from the conference, a couple of weeks go by, and I'm thinking, I got to talk more to Kent Beck. So I called him up, and we arranged a meeting, and I flew out to Medford, Oregon, where he was living, and he and I kind of collaborated and schemed and put this idea together to teach classes on extreme programming. Now, this is the height of the .com era, right? Everybody is spending money on software, right? If you had a J in your name anywhere, you could get hired as a Java programmer. So, this was a really crazy time. And Kent Beck and I think, okay, we're going to teach people extreme programming. And we designed a class which we taught. Kent Beck and I and Ron Jeffries and Martin Fowler and Ward Cunningham would all get together, and we'd get 60 or 70 people into a room, and we would yell at them for a week and teach them extreme programming. And it was very successful for about 2 years, right until 9/11. Right. And then 9/11 was the collapse of the .com era and the collapse of the computer industry for about a year, and everything kind of shut down at that point. But we had it really going. It was great. And in the midst of that, Kent Beck calls a conference of all of the people who know about extreme programming. He calls it the Extreme Leadership Conference. And we all go there, and it's back in Medford, Oregon, and we take cruises on the Rogue River, and we hike up the hills and things. And then we have conferences about extreme programming. And at one of those meetings, somebody said, well, we should start a nonprofit organization to promote extreme programming. And the mood in the room was, oh, no, we're not doing that. Not again. Because these are the same people who did that with the Patterns movement, and they didn't like the result. But I left that meeting thinking, no, we should do that. And I said so at the meeting. Martin Fowler followed me out and said, I think you're right, Bob. And Martin Fowler and I met a couple of weeks later in Chicago, and we composed a letter and sent it out to a bunch of people, Kent Beck and Ward Cunningham and a whole bunch of other folks as well, And the name of that letter the subject line of that letter was Lightweight Process Summit. And the idea here was that we wanted to get not just the extreme programming community, but the Scrum community, the FDD community, all these lightweight process guys. We wanted them all in one room to hammer out what was the same about all these processes. And we sent that email out. Alistair Coburn called me within a day, said, I was just about to send the same letter, but you've got a better invitation list. Can I add more people to the invitation list? And I promise I will do the legwork to get it all set up in Salt Lake City. And we said, yeah, go ahead. It's great. And so the meeting was created. I mean, we all wound up in Salt Lake City at Snowbird Ski Lodge in February, I think it was, of 2001, I think. And we all met in that goofball room up there and chitter-chattered for a very long time. And then came up with that manifesto, but almost by accident.
Are you surprised that it's been held in such high regard since that was created?
Yes, it's very surprising. If you've been a consultant long enough, you've been to lots of meetings like this. All right, where we're going to change the world with this meeting, or we're going to change the world with that meeting, and it never goes anywhere. And so that was my impression at the end of this one too. We put it up on a website. We did all this stuff. It was Ward Cunningham who had the brilliant idea of putting that manifesto up on a website and then letting people sign it. Now, this was 2001, and user modifiable websites were very rare. Right? Dynamic websites were rare. Usually, websites in those days were static. So the idea that you could put your name on the website was kind of unique. And he said he would do that, and he did. He put it up in a matter of a day or so. And we all flew home from that conference and thought, well, nothing's going to happen. It's just going to be like everything else that happens like this. And no, tens of thousands of people signed the damn thing. And all of a sudden we thought, oh my God, something's going on here. And it took off after that. And Ken Schwaber had the brilliant idea about a year later of teaching certified Scrum Master courses.
So from your perspective then, how many extreme programming projects had you overseen and kind of really tested the water of this new idea, this concept?
None. No, I hadn't done extreme programming at all, right? But I thought this is a good idea. Now, had there been extreme programming projects? Yes, Kent Beck and Ward Cunningham had done some, and Martin Fowler had done some, and they had a good track record. But from my point of view, it was just a good idea. I thought, yeah, this is the way software ought to be done. Why did I think that? Well, because it's awfully similar to the way I used to do software when I was a teenager. Right? Okay. So, yeah.
That's really interesting because, of course, so extreme programming projects had been run. So the idea had been sort of put through its paces, but it still feels like from that story, it still feels like it wasn't something that was like hammered out over the course of, I mean, maybe in some ways it was hammered out over the last 10 years, but the idea was put forward before really practice was. But I mean, there's nothing wrong with that. It's just an interesting way how something so monumental kind of was put in place from very little kind of actual projects going on.
Yeah, I think it's perfectly fair to say that it was not steeped in practice. And Kent Beck and Ward Cunningham and a few others had done projects for several years this way. But most of us at that meeting had not. And the Scrum guys had done some projects, and Alistair had looked at some projects that sort of did that. And you had John Kern from Pete Code's organization doing FDD, and that was sort of similar. And you had the DSDM folks, and that was sort of similar. But it is not true that there was decades of practice behind this. Moreover, it was just raw instinct. And it was raw instinct that was developed in reaction to the process that had dominated us for the previous 30 years, which had been the waterfall process, which was also started by nothing more than raw instinct. There was no good reason to do waterfall in the 1970s, except that somebody published a paper that made it look like, hey, that might be a good idea. This industry of ours is impossibly young. It's 70 some years old. I'm almost as old as it is. There are people alive today who were born before the first line of code was ever written, right? So we are still in the very young, immature stage of an industry. And this kind of revolution is not uncommon in immature industries. On the other side of that, our industry is growing exponentially. The number of programmers in the world doubles every 5 years or so. So not only are we immature, but we are highly populated. We are hundreds of millions of very immature.
Yeah, for sure. So you've been put on record, right, saying about consultants have ruined Scrum, right? Turned it into that it's sort of losing its roots and all the rest of it. I somewhat agree, to be honest. It's losing its lightweight. The idea behind it being lightweight. How do you feel about that? Like, as of today, do you still feel like maybe it's losing its essence a little bit? Do you think it's clawing it back? And with this overpopulation, I know there's too many questions right now, but what's the state of play right now, Bob?
So consultants ruin everything. Right?
I mean, I might have paraphrased that.
No, it's true, because consultants have to differentiate from one another. So I have to be different from Kent, and Kent has to be different from Martin, and everybody's got to be different. Otherwise, there'd be no reason to hire one over the other. So we must differentiate. And when you differentiate, you tend to add adjectives. We need to put adjectives onto things. So we cannot just have Scrum. We need to have new Scrum or reasoned Scrum or flexible Scrum or something. You've got to put adjectives in front of things. And that's what consultants do. Right? They do that kind of thing. And that tends to dilute the original message. Now, some of the ideas that consultants come up with are good ideas. I like to hope that I've come up with a couple of good ideas, but some of the ideas are good. But there is this general pollution and dilution of the idea. So Agile has gone through that, right? We've had all these churning consultants come along with different ideas of how to do Agile this way or how to do Agile that way. Some of the ideas are perfectly fine, but they dilute the original idea. So I wrote a book, Clean Agile, which tries to refocus everybody on the original idea. Just get everybody back to the beginning and say, hey, back to basics time. What was this really about? What should it be about? How are we going to take it into the future? That's just the way things go. And there's nothing unusual about it. I suppose you could say it's unfortunate, but it's also the way the industry evolves. All industries evolve that way, right? It's just you dilute things and then you refocus, and you dilute things and you refocus, and some new ideas come back in.
It seems to me that is, it's interesting that you mentioned that the stuff you were talking about with Agile is when it first started, is sort of the way you were doing stuff when you were a kid. And it kind of feels to me like there is a lot of cycles that we go through in our industry which are like that. As you said, we bloat things up and then we shrink them back down. And I think DevOps is a great example, because you start off with deploying things to live with the internet, and then you introduce all of these heavyweight processes to lock things down, and now we get to a point where everything's in everything is infrastructure as code, as we can control it all from our IDE. Do you feel the same, or am I off base there?
No, you're perfect. You're perfectly on base. I mean, when in the early days of programming, we were all doing DevOps because there wasn't anybody else to do that. We did all of our own installations. We did all of our maintenance. We did all of our. When I worked at a company in the 70s, and whenever a customer would call in with a problem with a product in the field, the receptionist would answer, and then the receptionist would get on the PA system and say, would someone from software please pick up Watts line 5-4? And someone from software would pick up Watts line 5-4 and say, hi, I'm Bob. What's your problem? We were the field service people. We wwere everything. We did everything.
You were literally on call. Yeah.
Of course. Yeah. I mean, And so then you had to divide labor up, and we had to split these people off. And all of a sudden, the whole world looks at it like, oh my God, there's these different kinds of people, and they do these different kinds of things. And then somebody finally comes along and says, no, they all do the same thing. It's DevOps. Don't you understand? It's just the same thing, widen and shrink and widen and shrink.
Absolutely. It just has to get a name, I suppose. Is that the thing?
Names are a big problem. Yeah.
One of the hardest problems in computer science, I believe, naming things.
Naming things, yeah. And off by one errors,
right?
Yeah.
Absolutely. We'll have to get that joke in somewhere. At least once an episode, maybe I should try that from the future. So obviously, we've talked for a while now. The one thing that we've probably missed out, or amongst many things, is clean code, right? So that's a big. I don't know how we managed to talk an hour without talking about clean code, but that's Uncle Bob and clean code go in the same sentence, really. And you mentioned briefly about testing before and not liking this whole testing first thing. Well, I have to say, Bob, I don't know how many bowling games I've written at this point, but I'm going to blame it on you. So, I mean, tell me, how did you get into the? What changed your mind about this whole testing first thing?
Oh, I told you that I called up Kent Beck, and I went out to Medford, Oregon to talk to him about doing these extreme programming classes. And as part of that, he and I sat down and wrote a little Java application using this test first programming idea of his. Because I told him, I think it's nonsense. And he said, well, here, let me show you. And for 2 hours, we sat there and I watched him, and I participated pair programming with him. I watched him move in the most impossibly small cycles I could imagine and getting things to work just one little bit at a time, it just absolutely floored me. I'd been a programmer for 30 years by that time. I didn't think someone was going to show me something incredibly new, just out of the blue, new. This was new. It was different. We managed to write a little Java application. It was he called it Sparkle. It was just the mouse would throw off sparkles like the magic wand of the fairy godmother in Cinderella, and that was the whole application. Right. And we never debugged it once. We got it working through a series of very tiny steps. And every step worked. And then we'd do the next step and it worked, and the next step and it worked. And by the time it was done, it was done. No debugging, no nonsense. And I went away from that thinking, okay, this is different. I need to learn this. I spent 2 years learning that really, really well. Mm-hmm. Yeah. So your mind can be changed, but it has to be by a significant event.
Yeah, I think it's probably, I think for a lot of developers it is a very hard thing to learn, especially if you've got a history of working in a different way. It sounds like you went through that yourself, actually, 2 years worth of trying to figure it out. Is it the only way you write these days, or do you still fall back on, I'm not going to test that bit, or I'm going to do it in a different way? Because it seems like there might be a bit of a movement against it almost.
Oh, there's always movements for and against. That's just kind of the normal way of things. Do I do that with everything? My plan is always to use test-driven development as my fallback discipline. There are things that are difficult to test, and it's not worth writing a test for. So I will sometimes break the discipline in favor of those kinds of things. If I'm working in a GUI, for example, it's very difficult to write a test that makes sure that the thing on the screen is exactly where it's supposed to be. So there are times when you think, okay, the only thing I can do here is write the code and look at the screen. But I try to get as much of it as possible tested by unit tests.
I mean, I would argue that is an element of testing. It's just whether that test is then repeatable.
And that is the problem. You can get it into a short cycle as long as you've tuned the application so you don't have large startup times and crazy configuration you have to do. If you can start the application and look on the screen, then you've got a nice short cycle. It's not repeatable, but at least you've got the short cycle.
Do you think there is we talked about things bloating and then getting shrunk down again. The number of programs that I've come across that have hundreds of thousands of tests, maybe that's an hyperbole, but but lots and lots of tests and take an awful long time to run. Do you have any suggestions or how to tune that, or whether people should be writing the right sort of tests?
Yeah, well, I mean, tests should not run for a long time. That's one of the design goals in test-driven development. And so I have gone through that process where I started a software project in 2001 called Fitness. My son and I started it. Several other people got involved. And the number of tests grew and grew and grew. It got into the thousands of tests. And the test time was on the order of 4 or 5 minutes. And that was just too long, right? Because you can't do the cycle when the test time is 5 minutes long. So I went through a period of refactoring. I said, okay, how do I speed this up? And I found a whole bunch of ways that I could cut time out of those tests, which I did, got it down to like a minute and a half, which was good. And then that's just part of the process, right? You're always looking for ways to streamline the tests so that you can get as many tests executed in the shortest possible amount of time. And that becomes a design challenge. Lots of people, when they write tests, don't think about the time. They don't think about design principles. They don't think about design rules. They don't treat the tests as part of the system. They treat the tests as something outside the system where the rules are different. And that's a fundamental error. The tests are not outside the system. They are part of the system. They have to be treated with the same level of respect and care that anything in the system is treated with. Same design principles apply. Same coupling rules apply. Everything applies to the test just as much as it applies to the regular code. And if you follow that rule, you will keep your tests running relatively quickly. They won't get overcoupled. You're not going to have the fragile test problem.
So what's your perspective then on like the sort of external QA of having people writing automated tests for a team? And that, should that be a developer's job? Is there a value in that external QA? What's your perspective?
There's certainly value in the external QA writing automated tests ahead of the team. QA people are the people who are not invested in the structure of the code. They don't have anything to prove about how well the code is designed. Their focus is on how well they can break it. And that's a very interesting mindset, right? They're evil. They want to break it. So they're designing tests that stress the code in a way that the programmers would probably subconsciously avoid. So that's a good thing, right?
Now, how do you get to them to do that up front? Because I think that's the hard thing.
Yes, you want them to do that up front. And that is the hard thing, because in order to do that up front, they have to think like programmers. And most QA people nowadays do not think like programmers. They look at the behavior of the system and they test the behavior of the system after the fact. And what you really want is someone ahead of time looking into the structure of the system and figuring out how to break it. It takes a programmer's mindset to do that. So a good QA person should be someone who understands code.
Yeah, I think that's important.
At least some of them, and it doesn't have to be all of them.
Do you think this is still a hard problem for us to solve in this industry?
Yes, it's a huge problem to solve, and it's a cultural problem, because we've set up this culture which has QA people after the fact who are little more than automatons, right? They just kind of go through a book and type this in and get the answer. Okay, that worked. And type this in and get the answer. And okay, that worked. And that's an abuse of a human mind, I think.
So let's return to the solid principles. Where did they come from? Where was the inspiration for the solid principles?
Solid principles arose in the midst of that social network that I was talking about, Usenet.
Oh, really? That long ago?
Somebody posted an article on comp.object, one of the news groups. And the name of the article was The 10 Commandments of Object-Oriented Programming. And it was the same old kind of stuff that you've read a dozen times, all your variables should be private, blah, 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 blah. And I thought, there are deeper rules than that. Now, I had just been engaged in a fairly significant project. My good friend and business partner, Jim Newkirk, and I made a pitch to a company in Princeton. And we built for them a set of 37 applications for testing whether architects were drawing blueprints correctly. Very interesting problem in computational geometry. And he and I and a team of about 6 people put together this suite of 36 applications, all in C++. And it was based on a fundamental framework. We had to come up with this framework that was reusable. And it turns out that making a reusable framework is really hard. It's not easy to do. So we completely screwed it up. And it took a year to screw it up. And then went to our customer and begged and said, look, we're sorry, we screwed this up. It's not working the way we thought. We're going to have to redo it. And we took it apart and we redid it. And in that, we learned a tremendous amount. So having gone through that experience, I'm looking at this article that says the 10 Commandments of Object-Oriented Programming, and I'm thinking, no, we learned some things. And I published an article in response to that one, laying out the things that we learned. And I gave the things that we learned names. And one of them was the Liskov substitution principle. And one of them was the open-closed principle, things that we had read in other books. And there were about 12 or 13 things that I put in that list. That was the beginning of the solid principles. From there, it kind of evolved into a suite of two different packages of different kinds of principles, component level principles and class level principles. The solid principles are the class principles. Then there's the component level principles below those. It kind of split apart. There was another principle added. The order changed. Lots of things happened. By around 2005, Michael Feathers came to me and said, if you change the order, the first letters spell the word solid. And I thought, oh, that's a really good idea. So that's how they became the solid principles.
And so that's what made it into Clean Code, the first book, right?
I don't know that the solid principles are in Clean Code. It's possible. They're definitely in a number of books that I've written. But the definitive description of those principles is in an earlier book that I wrote, which is Agile Software Development Principles, Patterns, and Practices. And that's where the definitive description of all those principles is. But that was before they had the name solid. So they occur in a different order, and they're presented in a slightly different way.
I don't think I've been in any technology job where they haven't been mentioned in 15 years. And so, they're so widely used. Are you aware of the impact that you've had on the technology industry in that sense? We talk about that. We talk about the Agile Manifesto. Like, that's a very, very broad impact.
I sit here in my cabin up north in Wisconsin, and I write a little bit of closure code and decide what book I'm going to write next, and debate with people on Facebook and Twitter. And so I can see that there's an impact. I'm not in the industry as a programmer anymore. I'm not sitting in a room with cubicles with other programmers, so I can't feel it that way. I do get invited to give talks. I get invited to teach classes, so I realize that there's an impact.
Yeah, I think it's very, very broad. The impact.
Another way to know that there's an impact is that there's a lot of people attacking it. So.
That's a very good point, actually. Yeah, I mean, I have seen some people coming out against the solid principles, but I was wondering whether it was just a backlash that you were receiving yourself.
I don't know that it's personal, but I mean, if you're a consultant and you need to make a name for yourself and you've got an idea, sometimes you might choose the option of trying to take pot shots at somebody else. It's not a great idea. I don't like that way of doing it, but okay, it's inevitable.
So you're always planning your next book then? I mean, I've read probably at least 4 or 5 of yours, I think, including the Clean Architecture one, and you've got the Clean Craftsmanship one has just come out, right? So what's next? Have you got a list?
The next, well, I don't have a list. And usually when I'm done with the book, I say, well, that's the last book. I don't have anything else to say to the world. I'm done. And then an idea percolates and I think, well, maybe I've got one more. So the one I'm working on now it's got a working title of Functional Programming. And it is a book about the pragmatics of functional programming, how you do it in order to do a real programming job, not an academic one.
What would you say? I mean, this is giving a sneak peek to your new book, right? But what is the what is the difference between pragmatic programming and academic programming?
Well, academic programming is something that you do to prove a point or to learn something or to demonstrate a possibility. Pragmatic programming is something you do because a customer is paying you. So it's a fundamental difference, and one has deadlines and one does not, and one has a whole bunch of people with expectations and the other one does not. So there's a very big difference, and lots of people investigate functional programming from a theoretical point of view. But this book will be about, okay, now you've got a customer and the customer wants something done and you've got a deadline. How are you going to use functional programming to bring that deadline in quicker?
What's your take then in terms of someone who didn't go to university, wasn't an academic. How often do you see that difference between that sort of academic programming versus the pragmatism, and what's the right way that people should be writing code, really?
What a fascinating
In
question.
3 minutes.
Once you get a job as a programmer, you're in the pragmatic world. You're no longer in the academic world. And the number of people who go through a psychic shock coming out of college and into industry is very large. It's probably close to 100%, because they suddenly realize that what they learned in school might have some value, but the procedures they learned in school bear no resemblance at all to what they're going to have to go through now when they're writing code for real customers with real deadlines. So there's a fundamental shift in mindset, and the universities are not good at teaching that. I don't think many of the professors have ever gone through it. So if you find a professor who has written code in anger, that's a valuable thing.
We may find one in the comments section.
I think that mind shift happens to just about everybody, and it's a very important mind shift. Now, having done that mind shift, then you look back at the academics and think, well, some of that academic stuff was pretty far out there, and I don't have any use for it over here in the pragmatic world. And that's what happened to functional programming. It also happened to object-oriented programming early on. And it took a long time for people to be able to bridge the gap and say, well, there are good ideas over here, and they need to be brought into the pragmatic world because they can make a difference. You just have to understand them properly and how to use them pragmatically. It takes a long time. I mean, we completely screwed up object-oriented programming for 20 years. Just because we didn't really understand what the benefit was.
So, I mean, as we sort of wrap up, what's next for you, Bob? What are we going to see from you next?
Well, that book is coming out next, and I don't know when, but I've told my publisher that I'd like to get the first draft done by Christmas, so we'll see about that. And beyond that, I'm damn near 70 years old, not quite, 69 still. So I've got a cabin up north. I like to sit and look at the lake. That's what I'm doing right now. You can't see the lake, but it's right there. And I've been bought myself an airplane about 2 years ago, just before COVID. And I've been flying that around, and I go fly and visit my grandchildren and take my wife and stuff like that. So
are you in a semi-retirement now then, Bob? Is that where you're getting to?
Well, it's hard to know, if I'm semi-retired. I work only when I want to, but I want to a lot. So, am I retired? I'm still making money, okay, still earning a living. On the other hand, if somebody says, hey, come on out and do this, I can go do whatever I want. So I can take whatever time I need. So it's sort of retirement, I guess, but not really.
Are there any other passion projects that you're working on other than the books?
Yes, I am working on a project called More Speech, which is a client for a network called Nostr, 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 which is a throwback to the original social network that I was talking about, that Usenet network. The interesting thing about that old social network is that it was entirely uncensorable. It was distributed. It was everywhere. There was no way anybody could get their fingers on it and change anything inside of it. So anybody could say anything, and there was nothing anybody could do about it. And that's what Nostr is. Nostr is a network that allows anybody to say anything at all, and there's not a damn thing you can do about it. It's not censorable, which is, I think, the future of all of our social networks. We've made this critical error in allowing individual companies to run social networks, and then they, of course, impose their will upon the people who publish on their networks. So More Speech is a client on the Nostr network. I'm writing it in Clojure. I'm having a blast doing that. It takes a lot of my time. And, it allows me to spend my days writing code if I'm not writing something else.
That's interesting. I mean, that's a very interesting take as well on the sort of power of a social network, I suppose, locked into a couple of different companies.
The power of those companies, yes.
Exactly. Because it does seem a little bit, against what the internet was started for, right?
It absolutely is. Right? It was supposed to be the great equalizer.
Yes. You would expect that, with everybody having their information at their fingertips, that you would have more informed people, but it just seems to make people louder, I guess. Thank you, Bob. Thank you for joining us, because
Oh,
it's
my
been
pleasure.
a pleasure. It's been a pleasure talking to you. I've wanted to talk to you for years, as I mentioned. And actually, I think it's good to have had a conversation with you where you're talking about sort of your enjoyment in argument. You are quite a pragmatic guy, I think. Contrary to what a lot of people have put out on the internet about you, and I think that you're approaching a lot of different things and trying a lot of different things, and I think that is great and has to be commended. And whether we disagree or agree politically or not, I think that is it's great, the impact that you've had on the world.
It's more valuable to disagree than to agree.
There you go.
Well, I think the one thing I've heard is when you hear about good minds think alike, I think that's wrong. I think good minds think differently, right?
Yes. And then synthesize.
Anyway, thank you for being on the show, Bob. It's been a pleasure talking to you.
Certainly. My pleasure. Lots of fun.
Thanks, Bob. I really like listening back to that talk. That was a really, really good conversation. I really liked that episode.
Yeah, really great to speak to the guy. And as I said, whilst I'm pretty certain we don't agree politically, I find it possible to set this aside to focus on the incredible things that he's achieved. And I think we can find inspiration in his approach to constantly moving forward, adopting new ways of working and breaking things down and simplifying when things have become too bloated or too complex.
And to be honest, overall, the conversation was just such a fun conversation. He's got a lot of energy, a lot of positivity about him, and made it very easy to kind of get over that almost starstruck, going into it a bit starstruck. Do you know what I mean? So really
lots of great stories.
Lots of great stories. So we'll be back in a week's time with Tamur Rashid, Chief Business Development Officer at Redis. So it's another big one for us. If you're new to the show and still listening at this point, then I want to sincerely thank you from the bottom of my heart. It really means the world to us that you're still listening and you're engaging with us. And without you, this kind of can't happen. So please, once again, like the episode, subscribe if you choose to or want to. Give us a follow and maybe head over to buymeacoffee.com/thattechshow and support the show. It really goes a long way. Check out 63 other episodes over on thattech.show or Apple Podcasts or Spotify, wherever you get your podcasts, and take us with you wherever you go inside of your earphones. And don't forget to give us a 5-star review on the podcasting apps. We're pretty sure that if we actually get more than a handful of reviews, it'll help others find the show. That whole algorithm stuff, I guess. Anyway, that's enough, and see you next time. Goodbye.
Goodbye.